Welcome everybody. I'm Marco Caselli. I'm presenting our work on specification mining for intrusion detection in network control system. My collaborators were Emmanuele Zambon, Johanna Amann, Sommer, and Kargl. I want to start with a few words about network intrusion detection. So since the 80s, intrusion detection has evolved into a number of different approaches. Among them, anomaly-based and specification-based intrusion detection have gained attention for their capabilities to detect previously unforeseen attacks. So, sorry for that. If anomaly-based leverages a learning phase to understand what a normal behavior is within an infrastructure, specification-based uses a different approaches. And instead of a learning phase, we leverage some functional specification and documentation to understand what a normal behavior is, and we use this as a reference point, as a reference to understand what is malicious. Specification-based is a nice approach, is a nice tool, but it has some drawbacks. Sorry, I cannot do anything. One of them is that not all the infrastructures we want to monitor come with specifications. So, of course, we need the specifications to use specification-based intrusion detection. The other drawback is that usually deploying a specification-based intrusion detection system requires a substantial human effort. So you need a person that reads the specifications and then manually write the rules that are included in the intrusion detection system. So our goal with this work was to ease the deployment of a specification-based intrusion detection and automatically create the specification rules. Okay, so to do that, to achieve that, we design a specification mining approach. And of course, our main sources of information are the network traffic we're going to monitor and the documentation, the functional specification, the configuration files. And an intrusion detection system that works with this specification mining approach goes through different phases. First of all, the intrusion detection system has to understand what we have on the network, so like fingerprint devices, understanding roles of the devices and their purposes. Then it uses this information to go and check if there are documents that explain how these devices should behave. And when we have extracted this information from the documentation, we can define some detection rules, some specification rules within the intrusion detection system. And after that comes the detection and, of course, the alerts. So we cannot apply this approach to all the infrastructure, generally apply this approach to any infrastructure. But we noticed that network control system suits this kind of approach. So network control system is a growing technology, and generally speaking, network control system are those systems whose constituents are sensors and actuators, and you have controllers managing these sensor actuators to manage, monitor a physical process. Controllers implement the control process by exchanging communication over a network. As I said, network control systems are a growing technology, and you can find them basically everywhere. You can find them in critical infrastructure as industrial control system, in IoT, smart cities, within building automation system, and even in vehicular networks. For this research, we focused on building automation systems. So all the systems that within a building monitor and manage services such as heating, ventilation, air conditioning, lighting, energy consumption, even security, so with smart locks, smart cameras. And we decided to focus on these systems because this is going to be likely the next low-hanging fruit for crackers. So if Nowadays, maybe an attacker needs a crowbar to enter your house. In the near future, it's plausible that these attackers may access the houses through building automation systems. And there are already researchers that have categorized kind of attacks you can pursue against building automation systems. And there was a NIST publication categorizing these attacks within these three classes, snooping. So the idea is that attackers may want to gather information within a building automation system, denial service, you want to make some controllers unavailable, process control subverting when the attacker wants to completely subvert a physical process monitored by the building automation system. So we knew, I talked about these two sources of information. Now let's see what this means within building automation system. For what concerns network traffic, we are going to monitor BACnet. BACnet is a protocol that allows controllers of different vendors to exchange information with each other. As you can see, it's a really comprehensive protocol. It implements different layers of the ISO stack. What we're going to monitor is the BACnet IP, so the implementation of BACnet over UDP IP. And I want to tell a couple of things more about BACnet, so how it works. There are two main principles here, objects and services. So the idea is that every controller, every smart sensor implements different BACnet objects that allow to describe any characteristic of that device, such as, for example, here an analog value, and every object has different properties further describing each aspect of the device. BACnet services are used instead to exchange information between two BACnet devices, so any device can ask for a specific object and some specific properties and make a computation out of the results it gets from the other device. For what concerns documentation, well, building automation comes with the heterogeneous documentation. In the paper, we analyzed different kinds of them. Here, I want to talk particularly about PICs, Protocol Implementation Conformance Statement. In fact, we noticed that every BACnet device comes with a Protocol Implementation Conformance Statement document. So the vendors has to tell what this device implements of BACnet. And these documents are just PDF files in which you can find a description of the device, and for what concerns BACnet, you find the services implemented, the objects, the properties that operators can use if they are deploying this device in their infrastructures. As I said, we had other kind of documentation we analyzed and we used, but for a lack of time, I cannot talk about them, so you can find the details on the paper. So we know what we're going to monitor. From one side, we have BACnet. From the other side, we have PICs. And what we needed were testing facilities. And we had access to two building automation systems. One was at the University of Twente in the Netherlands. The other one was at Lawrence Berkeley National Laboratory. Instead to implement the IDSs we deployed in these two facilities, we used Bro framework, and we used also some Python programs I'm going to discuss in a minute. To implement this approach, we had to give to the IDS the mechanism. We had to implement the mechanism to do system discovery, feature lookup, and rule definition. So I'm going to go through them step by step. First of all, system discovery. So we need some mechanisms for the IDS to identify devices communicating on the network and determining the roles and purposes. And we implemented several mechanisms and embedded these mechanisms within the IDSs. Here I'm going to discuss about a couple of them. First of all, we noticed that BACnet exchange a lot of information on the network that are freely available if you have a parser that actually can parse BACnet application messages. So Bro didn't have this feature. We implemented the BACnet parser. Now it's available on the main Bro repository. We use this BACnet parser to analyze the messages. And we use this BACnet device object analysis to understand what devices were communicating on the networks. In fact, you can see a lot of these messages on building automation systems just flowing around just because controllers need to keep information of each other. And this is nice because in this read property multiple services, you can see a lot of information about which is the vendor of the device that is communicating this, that is sending this message. You can find the model of the device, so you have a lot of information there. And this information actually allows us to link all the BACnet objects we see on the network to a specific device. In fact, thanks to the BACnet address linking mechanism, we see that the BACnet address gives us an information about which device belongs to which object belongs to which device, and this allows us to have a clear overview of what's going on the network. So we implemented this approach, and we were able to fingerprint 98.6% of all the devices that were on the two infrastructures, and basically 99.9% of the objects we saw on the network. Then we used this information to search for documentation. So we had a couple of choices. We could search for documentation over the internet, so the PICs are freely available over the internet. There are repositories for that, and we had also access to private repositories of the operators to find further documentation. So basically what we did was implementing and developing some Python programs that were using the information and like the keywords found on the network to search for documentation and pinpoint which document, which PICs belongs to which device. And with this, we were basically able to find PICs for every device that was deployed on the building automation network. What we had to do then is to understand what's in the PICs. So the PICs have different templates, so that was kind of difficult to parse the PICs in a general way, but we noticed that all the PICs share the same structure. So basically we developed a Python program that was able to go through the PDF and just pinpoint all the information about a specific BACnet device. And with this, we were just reading the PICs and so storing all the information about services, object properties, and all the characteristics. And so we had this information stored, and the last thing we needed to do is to translate this information in specification rules that the IDS can use. So to do that, we had to make a reasoning. So we knew that controllers were very important on the building automation system, and we knew that these controllers share some properties. So every controller had a limited set of variables to fulfill its functions, and all these variables were of predetermined types, and there were a limited set of services accessing these variables. So in the end, we kind of create and develop these abstract rules saying that we want to know which type of variables are in use, we want to know which values these variables assume, and we want to know the methods that are used to access these variables. And so the idea is that we had this type rule, and we developed a rule that says what a type is in a building automation system. And for us, a type, for example, was the BACnet object or the BACnet property that are in use. So when we have these BACnet type rules implemented within the IDS, we could automate the mapping of the information we found on the feature lookup to all the rules we created. So basically, the idea is that the IDS was able to take all the objects it found in the peaks and map these objects to the rules, saying that a specific device can use just the objects that the IDS identified within the documentation. So, recapping, we had an idea. We had two IDS deployed in the two building automation system, and these two IDS were able to find information on the networks, use that information to search over the internet and on private repositories about the documentation that links to the devices communicating on the network, and they were able to map this information to the rules to the general rules we gave to the intrusion detection systems. And with this in mind, we ran the IDSs for 2 months, and we had some results. So the IDS raised some alerts, and I mean, we didn't find any malicious activity per se, but we found some interesting activities going on, and it's worth to say that, I mean, those activities were unknown to the operators, so we actually improved the knowledge the operators had of their networks. And for example, we found a couple of devices using an object that wasn't supposed to be there. So the documentation didn't say anything about this proprietary object that a couple of Siemens devices were using. So we asked to the operators, they didn't know what this was, but then we figured out that basically Siemens was allowed to enter, to access the building automation networks and do its own analysis on some of its devices. So basically, this object was unknown to the operators because it's unknown in the documentation, but Siemens has its own mechanism to make analysis on its devices. And basically, I mean, this already says something about what an attacker may try to exploit without the operator even knowing that this is actually possible, because there is no information on the documentation. We found a lot of forbidden properties. So again, there were objects that were not supposed to have these properties, but still we found a lot of readings on properties that weren't supposed to be there. And all of these were misconfiguration. The operators didn't know that this was happening. And actually, we kind of confirmed all these misconfigurations, even in BACnet, because sometimes BACnet gives errors about a known property. But in any case, even this activity was unknown to the operators. And the most important thing, we found a property that, according to the documentation, wasn't supposed to be writable. And still, we found a message, we found an activity that was exactly writing a property in a specific device. And then we went back to the operators. We found out that it was an operator using some custom tool trying to write the property. So it was a mistake, and in the end, we were able to tell the operators that this was not supposed to happen. So I want to discuss a couple of points here about what we found, because we had also a big discussion about configuration mismatches versus security relevant events. So what we found were indeed configuration mismatches. So in the documentation, the documentation says something, and in the network we found something else. But still, I mean, what we found can be activities the attackers may want to go through to harm the system. I mean, the forbidden properties, the forbidden objects can be examples of an attacker snooping around trying to gather information from the network. And the writing, of course, could have been an example of an operator trying to subvert the system correct functioning. So, I mean, in the end, the operators agreed that this, what we found was interesting for them, and they asked us to deploy the system stably on their networks. Another discussion we had was about the attack coverage. Of course, I mean, if an attackers want to do something, manage to attack, to harm the system by playing within the specifications, we cannot detect that. So in this case, probably the use of other solution with the specification-based intrusion detection system we implemented, like standard anomaly-based intrusion detection, can help to overcome this problem. Finally, we discussed in the paper about the generalization of this approach beyond BACnet-based building automation system. We studied a couple of different technologies in building automation systems, like KNX and Loanworks, and also in those cases, we have all the principles and assumptions holding, because those two technologies allows us to read the network again, and the two technologies also propose some standard documentation that can help the operators to manage their networks, and in our case, can help us to build an intrusion detection system. And we even go beyond that, and we studied how and if this approach was feasible for industrial control system. In that case, you have documentation and controllers and the possibility to read the network, and in-vehicular networks, again, controllers within the cars that are communicating with each other, and we have also in that case some documentation that help us to understand what should be, what this communication should look like. In the end, I want to say that, I mean, we studied networked control technologies because this is a technology that is rapidly spreading, and most of all, I mean, this relates to a multitude of heterogeneous devices. And I mean, when we have these smart environments with such an heterogeneity, we need security solutions that can quickly scale up to all this. And manually tuning security solutions for that is not gonna be feasible. And our approach was exactly paving the way towards this kind of solutions. So we automated specification mining and rule description, and we obtained a specification-based IDS that was really efficient to deploy and was automatically adapting to the environment by understanding what was going on by itself. And said that, I will be happy to answer to any question. Thank you.
Hi, Antoine Lemay from École Polytechnique de Montréal. Very interesting work. I was just wondering where you plan, because I see you have planned to enlarge what your current model is, but I was wondering if you have other plans to expand what your model of specification is, because especially for industrial control systems, a lot of the time you want to know that the system behaves as conforms to policy for the engineering system. For example, that particular field might be within the specification of the protocol read-write, but by the engineering specification, it should be read-only. So do you have plan to expand your definition of what a specification is?
Yeah, thanks for the question. Yeah, first of all, I mean, the specification, the rules we used in the end are many more than what I showed here, but I didn't have time to discuss them, so you can find a little more already on the paper. For what you said about the policies, definitely, that's really interesting development. First of all, it depends on how you find these policies. We tested this approach, trying to search for manuals, for example, and trying to use natural language processing to understand a little more about how an infrastructure should behave. If you manage to find this information on a document, like a manual, yeah, you can try to develop.
So typically in industrial control systems, you have the integrator that implements the system that has a huge binder with engineering diagrams saying this does this and matches with all the specific registers and stuff like that. So this documentation is typically available at some place.
Yeah, thanks.
Hi, Greg Zabarucha.
Hi.
Is any BACnet traffic encrypted? And if it were, I mean, could your system still provide value?
Thanks. Well, no, but I have to say BACnet has the possibility to encrypt the traffic, so it's in the standard. The interesting thing is that nobody used them and no vendors implement the encryption. So basically, of course, if the traffic is encrypted and we cannot read the traffic, all the system won't work. But as far as I know, no infrastructure use BACnet encrypted traffic.
And so devices don't authenticate themselves to each other?
Absolutely not. That's a juicy part for the attackers. Basically, you can probe freely every device that you find on the network. And you can ask information on your own. I mean, you can do whatever you want there.
Okay, thanks.
Rich Johnson, NCAR. I noticed that your detection based on specifications will detect things that are out of spec, but what if an attacker is acting within spec and just changing devices? How would you extend to detect that kind of activity?
Yeah, as I said, I mean, we are definitely looking at the specification. So if an attacker knows that it can harm the system playing within the specification, our work won't alert any malicious activity. In that case, I can say either you have better specification, you can improve your documentation. If the operators have better documentation, we can try to improve our specification. But I would say that it's more likely to have this approach working in parallel with standard anomaly-based intrusion detection and try to overcome this problem with a different approach.